All right, so now what we're going to do is we're going to move from sensory and working memory and focus for a little bit on long-term memory, with a particular focus on amnesia. And to start this off, what I think we'll do is talk about a very famous patient, maybe the most famous patient, actually, now that I think about it in cognitive neuroscience, who is named, or referred to as patient HM. Actually, he passed away, and his name turned out to be Henry Molaison. And so this is him when he was very young. This is him older in life. He lived to be 82. He actually died relatively recently, I think in the last 10 years or something like that. And HM was one of these people who was having very severe epilepsy problems many, many, many decades ago, back in his 30s. And it turned out that what they ended up doing to cure his epilepsy was that they removed bilateral portions of his hippocampus. And so this is one of these cases, though, unfortunately, where back then when they did this surgery, they did not have the type of technology that we have nowadays to do the sort of electrophysiology recordings that we talked about earlier in this section when we were talking about place cells in the hippocampus and grid cells in the hippocampus. They really couldn't do the sort of work that they can do now to isolate where his epilepsy was coming from. And so what they ended up doing was a pretty crude, relatively speaking, procedure to remove bilateral hippocampus, which, just a reminder, are these regions in the medial temporal lobe. This is what the hippocampus looks like in a healthy individual. So what they ended up doing with patient HM was basically removing large swaths of his brain tissue on both sides of his medial temporal lobe. I'm going to now show you two cross sections of a healthy brain and patient HM's brain. And it looks something like this. And so this is what a typical hippocampus looks like, where you can see these regions down here and here, as well as these regions here and here. Whereas in HM, if you go all the way to the back, you can still see that there was some removal, but here you can really see how a lot has changed in his brain accordingly. And then for sort of a visualization of what it looked like, it was something kind of like this, where it was this huge swath of cortex for bilateral hippocampus that was removed. HM's brain is actually so, this is just kind of a fun fact, is actually so famous and so interesting. There were so many studies done with him. He was very willing to participate in research, that after he died, his brain was effectively, I don't really know what the term is, to be honest, like frozen in this sort of gelatinous blob. And the reason they did this is that then they could slice his brain up very, very thin, and then preserve each one of the slices to really trace all the connections between it, because they knew very well how his behavioral capabilities were. They knew what his behavioral capabilities were, rather. And so now with modern tools, they really are working to try to understand slice by slice which parts of the brain were connected to which part, and so on and so forth. So actually his brain is still being studied to this day. So the thing that was interesting about HM is that he had an above average IQ even after his surgery, which was around 118, which is actually quite good. His perceptual abilities were good. His attention abilities were fine. His comprehension, his reading, all these things were quite good in a lot of respects. The primary issue with him, however, was that he had permanent long-term memory issues. But unlike patient KF that we talked about in the previous unit, HM, had problems with long-term memory, but he had relatively normal short-term memory. Okay, so you ask him to remember phone numbers, he's going to do it just like you and I would, whereas KF would really struggle with that. Patient KF would not really be able to recognize, patient KF would be able to recognize, Kamala Harris, Jennifer Lawrence, Robert Downey Jr. HM would really struggle with something like that. And so here is just like a simple study where they would try to teach HM new words. So this is the number of trials that were required to learn the definitions and synonyms of new types of words. So you'd have to learn the definition of a new word, like recalcitrant. You'd have to learn a synonym of it. You'd have to then put it in a sentence. And so here in green, I'm going to show you how many trials it took for control people to get it. And then in orange and blue for HM at 2 different time points. And what you would see is data that would look something like this, where healthy individuals, they just need a couple of trials to learn what a new word is. Patient HM, actually, they stopped it after 20 trials. That was the max number of trials they wanted to do, because he just never was able to do it from one day to another, because unless it was in short-term memory, he was never going to be able to put new definitions, new synonyms, flexibly use words in a sentence in any sort of way, because that stuff generally requires long-term memory. They then did a follow-up where they wanted to make the task a little bit easier. So what they would do is they would give you these words, but then they would give you like multiple choice, like a list of options. Cause it's, if I give you the possibilities of like, oh, here's a word and here's like one possible definition, here's another, or here's possibilities for synonyms, or here's some possible sentences, which one of these sentences is the right use of this word, it's a little bit easier. And again, they would see how many trials it took for patient HM relative to controls. And in this case, eventually he sometimes could do it, but it would usually take hundreds and hundreds and hundreds of trials. And so he would really struggle, and there was really no improvement even after several years and so on and so forth. And so patient HM really is considered one of the most drastic cases of amnesia in history. It never got any better for pretty much the remainder of his life after the surgery. The woman who really was known for doing a lot of work with him was this professor at MIT named Suzanne Corkin, who has also since passed away. And the thing that she would say was very interesting is like she knew this guy HM for decades, and still after decades and decades and decades of interacting with him, she would pretty much have to introduce herself to him every single day. There were some signs that maybe he kind of implicitly remembered her a little bit, but every day she'd be like, "Hi, Henry, do you remember talking to me?" And he'd be like, "No, I'm sorry, I don't. Like, I'm Henry." And she'd be like, "Hi, I'm Suzanne. I'm Professor Corkin. Nice to meet you," so on and so forth. But one thing I do want to talk about is that while HM is a very famous type of amnesia, it's not the only type of amnesia, because in the same way that there are many types of memory, there are also many types of amnesia. And the biggest differentiation between amnesia is this differentiation between what's called anterograde and retrograde amnesia. So anterograde amnesia is basically an inability to form new memories going forward, whereas retrograde amnesia is an inability to remember things from your past. So you can have this moment in time, an injury, a surgery, something that causes the amnesia, and it can cause, depending on the parts of the brain that get damaged, either an inability to remember things. So, if you have retrograde amnesia, you'd get hit on the head, let's say, and you would not be able to remember what you did a week ago. That would be an example of retrograde amnesia, even though you could remember, things a week later from now. Whereas anterograde amnesia would be, after you get hit in the head, a couple days later, you do something, you don't remember it, but you remember exactly what happened to you right before the accident. So it's about, again, the deficit being either an inability to retrieve things from the past or an inability to create new memories going into the future. And the sorts of accidents that can cause this, like I said, it could be head trauma. For those of you who are athletes, I think two of the more common ones amongst athletes are men's football and women's soccer. I think it's usually the headers or something that have to do with women's soccer. I don't really know. I think in order, the three most common things are men's football, women's soccer, and then men's ice hockey. But, a lot of times it comes from things like being in a car accident, having, if you fall down the stairs, things like that. There's actually some famous case studies and some famous experiments done with ECT, which stands for electroconvulsive therapy. And what they would find is that they could do these experiments where they would, in say a year like 1975, which would be the present, ask about different types of questions related to TV shows, like, oh gosh. So, if we were trying to do something like this nowadays, what could a famous thing that happened on TV be? I should have thought about this. What happened to Walter White at the end of Breaking Bad? What, did he survive or did he die? What happened to, what is it that I've heard? I don't know if this is true. I've heard that a lot of college kids right now are watching that show, The Office, which I think is kind of dull and overrated. So what was the name of that guy? Oh, his name was Michael, like me. Like, what does Michael end up getting married at the end of The Office? I actually don't know. So these types of questions about things that happened further and further in the past. And what they found is that they could look at people's performance before they had electroconvulsive therapy and after they had electroconvulsive therapy. And what they would find is something that looked kind of like this, where the blue line is something like a typical forgetting curve, where you remember things that happened on television shows more recently, and you forget about things that happened on television shows further in the past. But it's kind of interesting because once these same patients, so the blue line and the red line are the same people, it's just before and after ECT, they find that those people who previously remembered stuff from 73, 74, they actually lost those memories. That's what this big dip is. But the thing that's interesting is that then you can see some bit of information is better able to be retrieved even going further back in time. So it's weird because it's like, oh, these things that happened more recently are harder to remember, but things that are in the middle are easier to remember, and then things that happen further in the past are, again, harder to remember. And again, in a situation like this, what's thought to be going on is that the electroconvulsive therapy can cause this sort of retrograde amnesia where there's this period of a deficit that goes backward, but it doesn't go all the way backward. So it's almost like this is where that dip is in the red line, then the red line peaks up a little bit, and then it, as you go further back and further back, it gets worse even still. There's also similar sorts of patterns in a disorder that's called Korsakoff syndrome. Korsakoff syndrome is a memory disorder that can occur in people who are very serious alcoholics, where I believe it's the chemical thiamine starts to get deposited in their brain, and it causes these problems. And so they have a very kind of unique type of amnesia. And what you can do is you can look at how well people with Korsakoff syndrome and how well patients can remember people associated with different decades. So I would say a name to you, and you would have to try to tell me which decade that person was associated with. So for example, if I said Jennifer Lawrence again, you'd probably be like, oh, the 2010s. If I was like Barack Obama, you'd be like, I guess Barack Obama's a little, he's primarily the 2010s as well. Or like Britney Spears, you'd be like 1990, or like Michael Jordan, 1990, and stuff like that. You would just have to kind of give them a sort of era of that form. And you would see how well these people will do. And so what you have here is in green, you have the control people, then you have the patients with Korsakoff's amnesia, but then you have also, they would do these experiments where they would get people who were alcoholics but did not have Korsakoff syndrome. Sorry, hold on, I have something in my throat. So to then put patient HM in this sort of, I've been showing you, I've been showing you this plot about different types of amnesia. And so to give you a sense of where HM fits into something like this, you can imagine that this green blue bar here is the lifespan of HM. This would be when his surgery occurs. And it's from there actually that he's not able to form new memories. So this is why I was saying the thing about with Professor Corkin, Suzanne Corkin, who was the physician and the professor who worked with him. He would never be able to remember her because he couldn't actually ever form a brand new memory. But then the thing that was interesting about HM is though he lost his memories also from about 2 years before the surgery. So he couldn't really remember that. But if you went further back into his life, he could remember those different types of things there. So HM was actually interesting because while a lot of people either have anterograde or retrograde amnesia, he actually had a little bit of both. He had pretty severe, almost entire anterograde amnesia, and he had a little bit of retrograde amnesia that went back some bit, but he had some memories from his serious youth. I think he might have been alive when like maybe Harry Truman or Eisenhower was president. He could remember stuff from his, childhood and from when he was, in his 20s or something, but then things got lost as they got closer and closer to the surgery. So I should also mention though, that in the same way that there's multiple types of amnesia, like anterograde and retrograde amnesia, there's also different types of long-term memory. And so actually when people try to plot out what a chart of long-term memory looks like, it gets actually pretty big, pretty gnarly, pretty complicated. So let's simplify it a little bit. It first focus on this differentiation between what's called declarative or explicit memories and more non-declarative memories or implicit memories, okay? So HM was interesting because he actually could form new non-declarative memories even if he was an amnesic overall, okay? So an example, of what a declarative memory would be is an explicit type of thing. So like for you all, hopefully, if I were to ask you, hey, everyone, where is primary visual cortex in your head? Please point to it. You would, and declarative and explicit memory would be like, oh, it's in the back of the head. I know that that is in the occipital lobe. If I was to ask you something like what the parts of a neuron were called, hopefully you could tell me, an axon and a dendrite. Another declarative memory could be like, what is the name of the Williams College mascot? Aren't they the Fs? The Fs, right? So those are examples of declarative memories. Non-declarative or implicit memories are things like riding a bike, tying your shoelace, things that you can do even if you don't necessarily like have an explicit declarative type of capability of describing them. Like I can tie my shoe, but if you ask me to describe how I would do it, I'd be like, oh, I don't really know. I just kind of do it. So HM could form new non-declarative memories, although he was a severe amnesic. And so one of the examples of the way he would have lost declarative but preserved non-declarative memories would be this sort of tracing task that he would do. And so what you would do is you would be lined up in such a way that you could see your hand and you could see a star in the reflection in a mirror, but you couldn't actually see your own hand. And so what you would try to do is try to keep your the pencil within the lines of the star. There would be like two little lines. You would try to trace the outline of the star without touching the lines. But you would be doing it in this mirror, so it's mirror reverse, so it looks a little weird. Have you ever tried to do the type of thing where it's like you move your hand one way, but like what you see is your hand going the other way? It's kind of tricky. It's a hard task to learn, but after a little bit of practice, you can get pretty good at it, but you know, it takes a little while to learn. And so here's what happens with HM in trying to do this sort of implicit, non-declarative sort of task over the course of several days and several trials. So on the first day, you can already see that he is getting severely or significantly better, that even on day one, he's better, or he's worse at the beginning than he is by the end. If by day two, he's better even still. And then by day three, he's really, really rather good. But here's the interesting part about HM. He has no memory of doing these tasks on the prior days. So every day that you do these experiments with him with this star tracing on day 1, 2, and 3, you have to explain it to him all over again. You have to explain the instructions, you have to explain the setup, you have to explain the mirror, the task, the lines, the star, et cetera, et cetera. He's like, no, I've never done this before. But then on day 3, he's like, oh my gosh, like snap, like I'm really rather good at this. And so this is one of these instances where you can see a dissociation between declarative and non-declarative memories, where he doesn't explicitly remember doing it, but he still seems to have some implicit knowledge of doing it. And so if amnesics have really as a whole taught us any lessons, it's a couple things. It's one, that the hippocampus and the medial temporal lobe are crucial for making these new long-term memories. But also they've showed us about how retrieving old memories and forming new memories must rely on different neural mechanisms, since we can see this dissociation between retrieving the old and forming the new. And then finally, what HM shows us as an amnesic is this differentiation between declarative and non-declarative memories, and that even when the hippocampus is destroyed, while you can't form these declarative explicit memories, you can form non-declarative implicit memories. Sorry. So I wanted to also talk just a little bit more about some of the memories underneath it. There are too many here to go into all of them. I don't want to spend as much time. But one differentiation I do want to talk about just a little bit is first episodic and semantic memory, which is this notion of this differentiation between memories of facts and memories of events. So for example, some sorts of examples of what memories of events could be: a specific personal experience from a time and place. Oh, do you remember that time we were in Boston and we went to this place and we had a picnic by the river? That's an episodic memory, whereas a semantic memory is something of a fact. Who was the first president of the United States? You hopefully know that it was George Washington. But if I asked you, when was the event where you learned that? You're like, oh gosh, I don't really know. Maybe something in school. If I were to ask you, what's another question? What are the other 4 colleges in the 5-college consortium? And you're like, UMass, Mount Holyoke, Smith, Hampshire. You probably can tell me that semantic fact, but you probably don't necessarily remember the event from which it happened. So even amongst just explicit memories, you can already see that there is a differentiation. I like talking about this one in particular because I personally have an unbelievably bad episodic memory, but I have a pretty good semantic memory. But my episodic memory is so bad that sometimes when I like get in fights with family members or friends of mine, and they'll be like, well, Michael, I'm only doing this because that one time you said blah, blah, blah. I'll be like, that's not fair. You know, I don't remember that. It's like a running joke because I just can't, I don't know why I can't remember events. Check these out if you're curious about all the different other types of implicit memories. For those of you who are athletes, you could probably be particularly interested in understand the differentiation between procedural memories, like, you know, motor skills, motor capabilities are obviously very different from a lot of other types of things. You can have motor memory, but not other types of implicit memories be really solidified, and so on and so forth. Okay, so why don't we take one last break there. When we come back, there will be one last section on memory, and the focus will actually just be, in this case, not on remembering, but focusing on forgetting. This will be a very short one, so actually it's only about 15 slides. So yeah, it'll be the quickest one.